Hello everyone. I hope I'm visible and audible as well. So, hello everyone, and I welcome you all again today to our second day of a 3-day webinar series on the topic of analog space missions. And today, particularly, we'll be talking about Nemo and the Neutral Buoyancy Lab as well, in short. So, I'm very sure you must. For some of you all, this must be new. For some of you all, you must have already ventured through it. And also an important notice for today that Eleanor won't be able to make it today, so I'll do the presentation. So bear with me. I won't take it long. I'll just talk for about 20 to 25 minutes, trying to answer some question of yours, and then we have Pablo with us, who will also give another 20 minutes talk, specifically focusing on plantation and analog missions, and that will be the agenda for today. So with this, I'll start with my presentation. Just let me know, Prasad, if my screen is visible or not. Okay. Is it visible, sir?
No, not it.
I think I'm
Yeah, it's visible now.
visible, right? Yes.
Okay.
Okay. So before we start talking about the actual Nemo or the Nemo missions, let's us all go back to the era of Apollo and specifically to Apollo 11. We all know Apollo 11 was a great, remarkable thing in the human history because we first landed on the moon and performed some tests as well. So, before Neil Armstrong could take small steps for man, he and the entire crew of Apollo 11 had to go through rigorous training, right? They performed tasks like collecting the geological specimens and other handling equipments and tools to train their muscles so that the muscles could reactivate the memory and perform the same task more efficiently when they are in the lunar environment. So, to make this training a much realistic and possible, the crew trained at various sites right here on Earth, which had similar topographical conditions as that of the moons. So the purpose of telling this is that doing analog missions is quite old. It's not something new. We have been doing it right from the era of Apollo. And the sites that was chosen to do the sampling test and equipment and tool testing and other training for the Apollo crew were the Cinder Lake Crater Field in Arizona, the Grand Canyon in Arizona, then Sierra Blanca in Texas, Nevada National Security Site in Nevada, and there were various locations in Hawaii as well. And in this picture, we can see Buzz Aldrin as well as Neil Armstrong who are
Uh,
preparing.
Ruchira,
Yes.
sorry to disturb you. Are you in presentation mode because we are still stuck on first slide itself?
Oh, can you see the Apollo 11 slide? Or
No, we are still on the first slide.
okay. Sorry, I'll reshare again. Now, is the slide visible of Apollo 11?
Yeah, it's okay now.
Yeah. So I was talking about this, and here in the picture we can see Buzz Aldrin and Neil Armstrong, who are testing the tools and equipments which they used for sampling the lunar rock and also for testing the lunar regolith. So Earth itself is a big analog, and Eleanor has given a wonderful insight to us on what are analog missions and how are they performed. So there are various environments as we talked of, and they are like terrestrial, aquatic, and laboratory. So terrestrial, as the name suggests, the analog missions which are conducted on land, and we have many like Habitat Mate, MDRS, and a lot. Talking about aquatic, to give examples that we'll be talking particularly in this presentation, the Neutral Buoyancy Laboratory by NASA, Aquarius Reef Base, Nemo, and the ESA also has one of its facility, which is the Neutral Buoyancy Facility. And to give an example of laboratory, I would say International Space Station, because it's the one of the biggest lab which we have built in the low Earth orbit of Earth, and we keep on experimenting, doing analysis, and trying to get data which will help us to venture our future space explorations, right? So, if you're talking about undersea research station, we cannot complete the topic without mentioning Scott Carpenter. So, who was he? So, Scott was the commander for the Mercury mission as well. He was and was also an astronaut. The first real link between space and sea environment started taking shape in back in the year 1965 when Scott signed for becoming the naval commander for Sea Lab 2, which was one of the submarines, which you can see here in the picture. So Sea Lab 1, 2, and 3 were experimental underwater habitats developed by the United States Navy in 1960 to prove that humans can live in isolation for extended periods of time. When he came, and his mission for was for about around 30 days, which is the longest of the analog missions that were performed. And when he came back after performing the mission, he said that the problems of putting man beneath the surface of sea are related in a number of ways to doing a task and making him effective for working in space. So, in short, his experience of working in space and under the sea was quite similar due to various reasons which we'll be discussing as we proceed with the presentation. So, NEMO, it's an acronym which stands for NASA Extreme Environment Mission Operations. And so, what actually happens here is it works on the main motto or the motive that is integrated operations. What does integrated operation means? It means putting people together so they can work together in the isolated or the confined environment. And we can see here in the pictures, the aquanaut is performing various tasks, which are mostly of the extravehicular activities, I would say. They're doing tools and testing, then tagging, collecting samples, as well as the regular EVA and machine testing, that is the ROV or robotic vehicle testing as well. So in NEMO or the NEMO analog missions, what we do is we put together scientists, engineers, astronauts, medical officers, sometimes naval divers as well, to perform certain mission objectives under this uh, simulated environment to to get some remarkable results which we can use for a future space travel. So where is it located exactly? So if you simply go and Google Aquarius habitat or go on Google Maps, you will come across this map and you can see here is Aquarius habitat. So Aquarius Reef Base, the world's only functioning undersea research station, is located about 5.4 miles, that is 9 kilometers off Key Largo in the Florida Keys National Marine Sanctuary. And it is about 62 feet below the surface and next to dip coral reef named Conch Reef. So this, I think you are able to see my pointer. This particular thing that you see is the Conch Reef, and this is the Florida Key Coast. And this facility is operated by the Florida International University. Here in the right corner, I hope you see this yellow thing here, right here, and it's the LSB, that is the light support buoy. Now, this actually connects with the habitat that's underneath the water. So there's this big tethered wire through which all the data is transferred and communication takes place with the mission control, which is there on the coast. So it won't be wrong to say that it's one of the only thing that is between the isolated aquanauts under the sea and the actual mission center, which is there on the coast. And also on the coast, there is an officer who will be there 24/7 monitoring the aquanauts, because if they need any assistance in case of emergency, he will be available to them. So the actual habitat Aquarius, you can see it here in the picture. It looks quite cylindrical and kind of a submarine, which it actually is. And there are a lot of thin things inside the submarine which are confined and placed properly with, space utilization. So we'll see and dive in what's inside the actual habitat. But first we'll talk about the dimensions and depth and all of it. So the diameter of the habitat is about 9 feet and it's 43 feet long. And the actual habitat that you see here, this cylindrical part, it is about 50 feet deep. And the legs on which it is based, it is about 60 to 62 feet deep. And in Aquarius, okay, so let's go and see what's inside the habitat. I won't play the video here. I'll simply go and show you. Yes, I hope this is visible, right?
Yeah, it is.
Yes. So if you go into Google Maps, here you can see here is Florida Keys. Here is the Aquarius habitat. You can click on the name itself, or you can simply go down and see the street view and 360-degree view. So let's see what's inside in the habitat. So where we are now. So this is where the astronauts sleep. These are the bunks. There are six in total. So a crew has about six members when they're for an analog Nemo mission. Here we can see a diver who's looking from the outside into the habitat. As we move ahead, this is the area where you'll see a number of instrumentation valves and knobs. These all instruments, this looks quite similar to the one we have on the ISS or on the spacecrafts, right? So these all measure various parameters like the oxygen level, carbon dioxide level, other vents and systems that are working properly or not. So you need to be very careful and keep checking on all of these. So if we move here we have a small dining table where they have their dinner and stuff. Then here we have a small kitchen area, a microwave, light, storage. And as you move outside, so this blue area, it's called as the wet porch, and this door itself is the hatch between the habitat and the wet porch. So, and this is your only way in and out of the habitat. So you can see, I hope you can see here, it's a bucket or a pot kind of thing. I hope you are able to see it. So it's used for transporting all the needs or of the equipment or even food or whatever it is required. It's actually loaded into these pots. It's then brought down by like it's then hangs from the ship. It's brought down and then comes into the habitat. And it's this small container which has everything that is needed for survival. So that's the only thing that goes up and down to fulfill your needs, to give you all that you need. And this is the door through which you come in and out of the habitat. And it's like I think that's fascinating because it looks quite similar to International Space Station when we are looking inside. So let's see what's a day in the life of Nemo Aquanaut. So the day begins with their preparation for the extravehicular activity. Then they go out through that door through that only way that we saw right now, and then they go explore the reef and locate the sites which have already been marked by the previous missions. Then they identify the samples. They tag the samples. Tag as in they put a mark or keep a data of those samples, and they are continuously in contact with the IVA, that is the someone who is there handling inside the habitat, and the one that are in the mission control as well. Then they collect data, they provide the data that is necessary, and also they do the sampling procedures as well, because we are aware that we need to sample rocks on different like moon on Mars to understand the geology of the rocks, and in short to understand how life or astrobiology evolved there, because they two are quite related. So this is what goes on into the life of or a day of a Nemo astronaut aquanaut. And here I have taken a picture of the Nemo Mission 22. And the overview is they had a 10-day successful mission and they worked in the Aquarius Reef base. They completed a combination of exploration of the extravehicular activity and the International Space Station related objectives. Then, as we say that Nemo is operated by NASA, but along with it, there are a number of space agencies, research institutions, universities, and industry partners who work together to accomplish the mission. So there were like four crew members in this mission, and you can see two of them were from NASA, one from ESA, that is the European Space Agency, and one was from USF, that is the University of Southern Florida. So during the entire mission, the activities, we can broadly classify them into the two categories, that is intravehicular activities and extravehicular activities. So let's talk about the intravehicular activities. As the name suggests, intra as in to stay inside the habitat or the module and perform the task. So while like there were four crew members, so it is mandatory for at least two members to do the EVA. so that you have assistance from the other in case of emergency. So at least two people should do the extravehicular activities, and the remaining staff would stay back and do the intravehicular activities. So the staff tested various procedures and equipments and tools, starting with the AR assisted procedures. AR stands for the augmented reality. The Aquanauts, now talking about the augmented reality, they're using the HoloLens, which helps them to there are images fed in which help them to merge with the reality and perform tasks more easily, and the lens guides them, navigates them so they can move easily through the habitat. And also, when we are living in a confined place, every instrument, everything is placed in order and is packed tight, right? You need to be very careful when you're removing something out or when you're putting something in, and sometimes you might not remember where a particular thing is. So this lens might help you to guide and see exactly where it is and just take that particular thing out instead of messing everything up. So they tested the augmented reality procedures as well. Then there we have VETTS, that is the virtual exercise training tools and softwares. So we know that when we're talking about astronauts or aquanauts, exercise plays a very important role because they need to maintain their physique in order to perform the mission and the heavy extravehicular activities. So that as we have this Google Assistant concept here, right? We use it for various tasks and for guiding us sometimes. So similarly, they're trying to create a virtual assistant which will keep them, which will help actually to keep the record of how as the body of aquanauts or astro aquanauts is is performing and how exercise is helping them to remain in the best shape. So they are testing that as well. And they are also testing the mobi pp, which is a European Space Agency designed tool. Again, it's a small, I wouldn't say a lens or a spec kind of thing, but a small equipment or a gadget that you just wear. And when you're performing spacewalk or when you're doing activities outside the International Space Station, your hands are completely occupied, right? You're working with the tools on it. So moving from one place to another when hands are occupied becomes a little difficult. So what this Mobi PV will do is what it will sense the command and it will help you through sensors to move. It will improve your mobility when you're doing the extravehicular activity on the ISS or on the spacecraft. So that is one of the purpose of the MOVI BP. Then they're also trying to use the nutritional tests. There's one gadget that will be with you and will try to keep up with your vitals, nutrition intake, and so that you maintain the best health possible. And then talking about the DNA sequencer, before the DNA sequencing was done on the International Space Station, it was actually tested in the one of the Nemo missions. So I would say that through this example, we can see how we are dependent on the analog missions, because any technology that is being, developed for space use is first tested in analog missions, so that if there are any drawbacks or any key for improvement, we can work them here out on Earth and then send an efficient and optimum working instrument or equipment out there in space. Because if we do not check what's wrong with the equipment and send it like that itself out, then it might hamper the entire mission objectives. So this highlights how important it is for doing analogs and testing equipments and technology in the analog itself before sending it directly into space. So talking about the extravehicular activities, throughout the mission, the crew perform core sample acquisition, then the equipment transportation. This is very interesting. The third one, Lunar Evacuation System Assembly. I'll talk about this in depth in the next slide. And then there is augmented vision heads-up display. So I am very sure in the first one you must have guessed what it is about. So if you're talking about going to Moon and Mars, we will do a lot of extravehicular experiments there, that will go out, we'll sample things, we'll try to get the samples from the rock, soil, to study it better for improving our habitats on the alien environments, right? So also you must be thinking, what's the need of doing it in person, right? Because we have rovers like, for example, Perseverance, which is trying to get samples, and we are working on the mission to get the samples back. But the amount of sample that we'll get from the robotic or the rovers is very less, and we can't perform every possible test on it. So if we are trying to explore more, if we are trying to understand Mars or Moon, more interest, like in more depth, we'll have to someday go there and do test by ourselves. So core sample acquisition will play a very important role when we are actually working outside there on Moon and Mars and trying to sample various samples of the soil or the rocks. Then the equipment transportation. So here you can see the crew is trying to transport manually heavy equipments and tools. And this will play a role when we are on Moon and Mars and trying to build colonies where we have to move loads by ourselves when we are already having the gears and the suit. So this training will come in handy when we are trying to work there, building our colonies. Then the last one is the augmented vision heads up display. I'm sure like we all like all of us are Iron Man fans, right? And we have always seen whenever he puts on his helmet, we see all this data running, right? That's extreme, but this idea of augmented vision heads display comes from the naval helmet that the naval divers use. So the research is that they're trying to use this specific augmented vision heads up display to improve our spacesuit design so that we can use this helmet in a future space travels. So as I was saying, the most interesting for me, and I hope for you, will be the lunar evacuation system assembly. So what exactly it is? So this was a concept suggested by the European Space Agency at the European Astronaut Center. So as the slide reads, it is incapacitated EVA crew rescue. Incapacitated as in you're out there on Moon on Mars and you're performing EVA, and due to some reasons, one of the member is injured or is facing some health issues. So you have to take back that member to the habitat or to the rover or to the area where is safe, where you can perform some surgeries or give him an assistance, right? So this was the concept of the mission that was being tested here in the we can see in the pictures. So lunar evacuation system assembly. So what they tried to do was they tried to one of the astronaut is here on the rescue pad. I would say he's lying down there. The other one is trying to build it, assemble it, put the one who is injured into it, and then trying to pull it back to the habitat to the rover so they can try to make him feel better, and if there's extreme so requirement of assistance of medical assistance, they can perform it in the habitat. So when they were performing this, they after performing what they came up with three key takeaways, and they were like the second that the astronaut who's trying to pull, he suggested that if we in the space suit design, if we consider having some attachment points so that it will be easier to pull, right? And the second observation and suggestion that the aquanauts made was that the entire rescue module could be made a more portable and smaller in size because it was difficult for a single person to manage it and do it. So that were the two key takeaways, and now they are working on this key takeaways to improve it so that we can use them in the upcoming missions. So here I have listed the Nemo Aquanauts, and we can see there are two categories. Astronaut Aquanauts, we can see there are about 54, as the name suggests. Astronaut Aquanauts are those who have been both into this space as well as under the sea, that is in Nemo missions as well. And the second category, that is engineer or scientist aquanauts, the ones who have participated in the Nemo missions but have not had the opportunity to go into the space. And Nicole Stott was one of the astronaut aquanaut. And when she was asked like what was her experience about both, she said that underwater it's like you are surrounded by the planet. And when you go to space, it's like you are surrounding the planet. And she said that the view from both of the missions was remarkable and it changed her perspective on how life is, which I think is I would love to have this opportunity to see both the views because I would definitely agree with her that it will definitely change my view of looking towards life, towards how we have, as a species have evolved and how we are trying to learn about ourselves by doing this space exploration missions. So what is the purpose of doing Nemo mission or any analog mission? It is like to test technologies and equipment. So let's see what technologies are being tested in Nemo mission for the future space explorations, which we'll be using in our future deep space explorations. So first is the EVA integrated informatics, digital cue cards, and traverse maps. So let's focus on three words: digital cue cards. So as we all know, whenever we are performing any mission in space, there's always a communication delay. So if there's a critical situation, the astronauts cannot just wait still there to just receive the command from the mission control center. So they have to act on their own and try to, handle the situation. So if they lose the track of what to do and what not to do, they have this cue card, which on this iPad, which they can just click on the options. They'll have all the instructions, procedures of how to do a particular task, what all is required, so they can follow it up and not wait for the communication delay or not wait for the mission control to give the command. So that is one of the like the motive behind the digital cue card, and it's been tested in the Nemo mission. Then there is traverse maps. um, what I understand is most of our space missions are like scripted. Scripted as in we know what we are going to do, when we are going to do, where we are going to do. So this maps helps us navigate through that points to connect those points and perform the mission in the allotted times. Then second thing is the EVA navigation and robotic operations. We are very familiar with this. We use a number of rovers, robots for space exploration, and they're tested on the ocean floor as well. Here we see one of the ROV, that is a robotic vehicle, but this could not survive as there were some technical issues, and also there were issues due to the sea weather as well. And the last that we discussed was the augmented vision heads-up display, which will also be used in the deep space missions. So, what are the similarities between the underwater space analog space missions and the actual missions in, which we perform in space? So, I have tried to come up with some so that you can understand the importance of the underwater research that we are doing for space exploration. So, the very first is the comparison between the habitat or the module. We just saw the interior of Nemo, right? You saw it was very confined. Everything has been allotted a specific space. To move also you have a limited space. Same is the case in International Space Station. You just can't roam about anywhere, right? Everything is in its place, confined for a particular task. And also the resources that are provided to for the Nemo analog missions or the International Space Station are all limited, so we need to use them efficiently. Second thing is the hazards. Like when we are in Nemo, we face danger from the ocean currents, the hurricanes or tsunami, anything that is going to come up. But we already get the data so that we can evacuate the Nemo facility. And in the case of ISS, we face the hazard of space radiation, vacuum, hostile environment. And in both the cases, you are like completely in an hostile environment. You're not connected with anyone like on Earth. But like as the technology advanced, now we are able to like call on International Space Station. But that could be one of the similarities. The second is the spacewalk. You must have seen many a times whenever one is performing a spacewalk or doing the extravehicular activity outside the International Space Station, they're always tethered to the station or to the robotic arm. The similar thing we see in the Nemo case, and here it is called as the umbilical management. The cord is called as the umbilical cord. And when the astronauts are performing the EVA in the Nemo mission, they are connected by the umbilical through to the habitat, so that they are not lost. But one care that you have to take in both the cases is that you don't tangle into each other, right? And you don't tie a knot, because that would create a major problem. So that is one of the similarities between Nemo and that is the mission underwater and the missions that we perform in space. This is the decomp procedure or the decompression procedure. I am sure many of you must have heard about this. So whenever an astronaut is going out of the International Space Station, what he'll do is there'll be about 24 before 24 hours, like the or 4 hours, he'll try to do the decompression procedure where he'll try to breathe in pure oxygen. Now, due to the change in the pressure, what happens is there are nitrogen bubbles that form in our blood, and that if and that results into dizziness and then paralysis, and sometimes if it's like too much, it can be fatal. So the most similarity is that when we are going to do the EVA out, we are moving out of the spacecraft, we are doing the decompression procedure on the International Space Station. And in the Nemo case, when the mission is over and you're about to return back on the Earth's surface, the last day the Nemo Aquanauts will do the decompression procedure for the similar cause, right? So this is one of the similarities. And there are many other similarities, like you can see the EVA that Nemo missions have done till date will actually help us when we are doing EVA out on Moon and Mars, and also in the upcoming future exploration. So that's all from my side. I hope you all have enjoyed. And now I like to take questions or like to discuss. Before that, just a little bit about Neutral Buoyancy Laboratory. We cannot say it as an analog mission or an analog area, but it's a facility by NASA that I'm talking about. It's 40 feet deep, and it has a mock of the International Space Station, like under the water, and the astronauts are given the training of performing the spacewalk and performing the EVA on the International Space Station in this particular laboratory with the assistance of the divers and the NBL lab people who are working there. So, yes, that's all from my side, and let's discuss. I'll stop sharing and then I'll come back. So, are there any questions? You can type them. Yes, Karine has given us another, that is underwater analog habitat in Europe. You guys can definitely check. She's provided us with the link as well. Thank you, Karine. Yes, what do astronauts do in case of unforeseen situation which arise and which isn't kind of scripted? Of course, they are also trained for that scenarios as well. So in that case, they'll have to take their own decision, which they do, and try to do try to try to not panic and come up with the optimal solution which will help everyone and not mostly hamper the mission and the mission objectives. Is Nemo and ISS 100% similar? um, I did not wanted to convey this. It's not 100% similar, but I was trying to give you a brief idea about how doing missions underwater will help us doing the missions in space. So it is kind of similar in most of the conditions. If you guys have any questions, you can type them in the chat, or else we have Pablo who will talk to us about. You guys wanted to know more about how we are going to plant trees in the analog like the habitats. So he'll talk more about that. So I'll give you 5 minutes. If you have any questions, type them into the chat box. I'll try to answer. If not, then we can move on with Pablo's presentation. And I was expecting the same question. How is there no water inside the Nemo as it is underwater? That's very true. Actually, the habitat is pressurized, right? So there's this pressure maintained so that the water doesn't slide into the habitat. How is the radiation issue simulated and prevented during space missions? Okay, I don't have a perfect answer for this, but I'll try to get it and give you the answer about this. Are there any other questions, or I'd like to call Pablo?
Chira, are you there?
Yes, yes.
Yes.
I,
So you can say me when it started?
can you repeat, Pablo?
You can say me when it started?
You can start now. I've given you the
Ah,
host controls. I
okay.
think yes,
I can start now?
yes, yes, sure.
Okay. Good morning, every people. My
Uh,
name is. You can say me? You can say all?
yes, yes. Now we can see you.
Anybody say me? Okay. My name is Pablo Vivanco. I'm from Chile. And I present to you my experience for that is my work in Chile. I'm working to. You can see my image.
Yes.
Anybody can see?
Yes.
Okay.
Yes.
Okay. I'm working to the policy implementation. This year, the last year, in Latin America Cooperation Overview, David Turner is the chief to prepare to different kind of terms for priority in the South American world. Everybody knows who is the COVID problem, and they be different kind of items for working in that project, and we work in Chile, and this situation, we don't have space agency because the space technology is recently, and we created that is we have private complement accords, and we create a new center for in the Atacama Desert with company that name Rocket Lab. I know Peter Beck. We worked in a few years with started the new project in New Zealand, and in Chile we have a little condition for to create a new space center to apply and apply for start training to the analog missions. So we created orbital rocket. This is a little experiment rocket. We can found to start initiated the program in the Habitat Marte Brazil. We created different kind of apply. This apply has in agriculture, and we base it in our experience of the Chilean experience. And space is we have controlled to different kind of species in that is project. So in the new project, we can create a new space habitat homolog in the desert of Atacama. So we can do, who we can do. Our work is represent different kind of projects around the world. Uh, why Chile? Chile is have a particular have a particular for priorities for to adapted species. We have in the north the desert. We have in the south to Antarctic. We have to the east to the mountain, and we have to the west to the ocean. That is a particularity conditions for the start training. We created a new program to the startup with the NASA Council the last year, and in 21 we participated in the Atacama, and we can participate in Habitat Marte mission, present that different kind of species like the new design of the project, and like the Mars transporting architecture is a new era for Starship program, and we can to try to understand who is our functional strategy. Okay, sorry about my English, but we can create the new mechanism for international executive agreements, and we need to create Artemis Accords. So uh, we created this program, adaptation of short cycle seed of cultivation in analog lunar regolith model. This is our first project. Who is that this? The timeline is recreate the lunar regolith with a chemical and mechanism similarity to about 18%. We propose have 4 short cycle plant species for selection or a future vegetal adaptation. We can to establish the appropriate environment conditions to the germination of the new seeds in the moon and in the Mars. And we can create the germination and observation of plants, hormones, and the adaptation in analog lunar regolith sample. This project we can we was presented with Asclepios project, and we can continue it to Artemis Accords, please. I'm sorry, with Karen Feldstein. she's a associated administrator. She know me, and this week, we can speak with a new project to the Habitat Marte. So, who we can do that this project with the AstroCapsule project and Habitat Marte project. I pretend to you present the next week to the Chilean Navy a new project for the new rocket for start the studies and create it to new apply a new place in the Antarctic in the first time, and the second time we can create Habitat Marte Atacama for start a new analog station, and we can buy a new different kind of technologies around the world for start a new private analog station. So I'm here. I'm speak with you. I'm happy for to participate in this meeting. I'm sorry for my English. I need to try to speak more better. But any question if you have, I can respond. Thank you.
Thank you, Pablo. And he's trying to work in the Atacama Desert because it is one of the driest place here on the Earth, and is quite similar to that. We can compare it to Mars. So he's also trying to study how we could grow plants. And can you show the um plants that you grown using the soil from the Atacama Desert?
We detected one place in the Atacama Desert that's named listen that it's Kiawa is the most dry place in the world. Okay, this located in Atacama Desert, in the heart of in the most Atacama Desert important place. In Kiawa, we selected this species. Anybody say? Oh, I'm sorry. Anybody say this species is a particularity. The most important particularity in this species is this species can't we can't to adaptate in the Moon and Mars. Okay, in Atacama and Antarctic place, we can create a new place for start the training analog missions. Okay. Anybody knows Eden Station in Antarctic? Ruchira, you know the project of the Europe Space Station in Antarctic?
Yes, yes.
Yeah, I go. I will go. I
So
was
you have
go.
been there.
Yeah, I know the Eden. I was go to the Antarctic six times for the Chilean Navy. I can present to you the chief command and the Chilean Navy was to go to the Antarctic. And this year I will go to return to the Antarctic, but we need to know who is the new scientists and new teams for maybe we got to go analog station and a new project. Okay. I'm speak with this time with Professor Julio Resende that Habitat Marte, and we started the study for the new project in this time. So the very important is AstroCapsule team is new created new forms of different kind of countries to participate in South America, and we need to come to go for Silicon Valley for present that a new project. Okay, the started training in homolog programs is very important. Okay, we pretend to go to SpaceX for buy one of that this technology, because this technology is very important in a new colony. Okay, so that is.
Yeah.
Thank you.
Yes. Pablo, we have a question for you. One participant wants to know the plant, like the species of the plant that you have grown in that experiment.
Yeah, we have four kind of species of the plants. Short cycle. We identified three more most important species: tomatoes, potatoes, gremlins, who is that? Who's the name? Sea mice, popcorn, and the most important species we can study is the potatoes and the gremlins. That name is lactuk. We can send the study and we can prepare to a new presentation for this project. It's very important to know the people for try to understand. ISRO working in the south side of the moon, and we need to try to understand who is the water systems in the moon for try to adapt it a great correct project to the vegetable species. Asclepios will go to the south of the moon, okay? And Eleanor Poli is very important in this project because she needs to work, she needs to explain who is the great project for the APLI, a new analog project, for the help us that project to that is. I'm so excited for to know Ellie for to speak with Eleanor tomorrow because Eleanor participated in Habitat Marty 2. And I say again, it's a great project. AstroCapsule is a great project too. India has a particularity, great experience in creating new technology. So we need to try to walking in around the world for the more better experience in 22. So
Yes.
thank you for all team, thank you for all people to that is in this meeting. It's very important to know this technology in this era. Okay. You have my email, you have my contact, you have my connected, and thank you for
Thank you,
starting
Pablo.
today.
We have Kareen with us. Kareen, would you like to come up and talk a bit? Because it's been so nice that you're attending our event and you're trying to answer a lot of questions, I can say.
Yeah, hello.
Hi.
Hi, Ruchira, and muchas gracias, Pablo.
Hi, Karim.
Era muy interesante
Yeah, you're a very great person, huh?
lo que tú haces.
Ah, you speak Spanish.
Claro.
Nice.
¿Cómo que no? Sí,
Uh,
yeah, so it's very interesting to learn about analog missions around the world and with different goals. Yeah, my name is Karin. I'm from Slovakia, and I am involved in a couple of analog missions. I'm an official cooperation partner of Habitat Marte, and I'm a flight plan and trainer for the the Austrian Space Forum, who is conducting the Amade missions. So I've been in the Mission Support Center last October for an entire month to support the mission in the Negev Desert in Israel, and which is an extremely high fidelity mission. That means it's very close to the real thing. We're using not spacesuits, but spacesuit simulators, which is a big difference because these suits, you cannot use them in space, but they simulate how it would feel to have such a spacesuit put on in Mars. Like the real thing would weigh like 150 kilos. The simulator weighs 50 kilos to adjust for the different gravity that we have on Earth compared to Mars. So what would weigh, if we send 150 kilo spacesuit to Mars, it would weigh there the equivalent of 50 kilos. And we're doing a lot of experiments in these missions in different areas. It's technological experiments, medical, biomedical, physiological, psychological, geological. So it's actually quite interesting being part of all this. And I've been in 4 virtual analog missions in Habitat Marte. I have very closely followed the last mission of Hydronaut in Czech Republic, which is the underwater habitat which we have in Europe. And that is, of course, from a psychological perspective, it's a lot closer to actually being in space than a mission on land, a simulated mission on land, because just like if you're on the space station or on the moon, you cannot just open the door and walk out. And you can't do that in an underwater habitat, at least not if it's a couple of meters below surface and you're doing saturation diving. It depending on how deep the habitat is placed, it can actually take longer to decompress and get back to the surface than it takes to get back to Earth from the ISS. Imagine that. So the psychological component in underwater missions is a lot more similar to what we will expect experience in space. Yeah, so this is kind of a bit of my experience. I don't know if you have any questions or there is anything in particular you want me to talk about. And yeah, there was a question before, if we simulate radiation and radiation protection on Earth. Yeah, we have actually had a radiation protection experiment in the Amade 20 mission. That the astronauts were given radiation protection vests that they had to wear, and they had to kind of test how comfortable they are, if they can sleep in these vests. But we cannot really simulate the exposure to radiation because that would be very unethical, because that is damaging the health of the analog astronauts. So we can't do that for ethical reasons.
Thank you, Karine, for answering that question. And also, it was interesting to know about how we are working on these space suits. Like, yeah, that was very interesting. And I would like to mention, like, it's tomorrow, right, Karine? You're giving a talk as well, if people are interested.
Yes, I am. Yeah.
Yes, so if you guys are interested, you can go and check out Habitat Marte. You'll find the link for tomorrow's presentation, which will be done by Karine. And I myself have attended one of her presentations, and I'm very sure you'll learn a lot of things. So if you're interested, you can just go on Habitat Marte's website and you can find the link. Once
Actually,
again,
I'm just putting the link into the chat because it's not on Habitat Marte's main website, Habitat Marte blogspot.com. There it is.
Thank you, Karine.
Yeah. You're interested, you're welcome to join. If you can't join, it will be on Habitat Marte's YouTube channel.
Yes.
Yeah.
Yes, thank you, Karine. Thank you for coming here and talking and providing your views as well.
You're very welcome.
Yes.
And if any one of you would like to join a virtual analog mission in Habitat Marte, I just put the contact details in the chat, and you can just just get in touch with Professor Giulio, who is the director of Habitat Marte.
Yes, you've already provided the link, so I guess many of them must have already checked it.
Yeah.
Yes, so I think with this, we don't have any other questions. So we'll end today's session, and tomorrow we'll meet again on the third and the last day of the webinar series, and we'll have Eleanor tomorrow with us. Tomorrow's session won't be a presentation thing, but we'll ask a lot of questions to Eleanor about her personal mission and her experiences. So I would like you all to come up with some questions as well. I have some couple of questions from my side. So, and there's a link in the chat box. Before leaving the meeting, please fill in the link and provide us with the questions that you would like to ask her or any feedback. And with this, see you all tomorrow. Thank you for joining in today. Thank you, Pablo and Karine, for
Okay, see you tomorrow. Thank you for this meeting. It's very, very important. It's a great honor to participate. Thank you for all.
We're glad, Pablo, to have you.
Bye bye. Have a good
Bye.
day.